The pace and scale of modern business puts traditional data architectures on their heels. To keep user-facing apps running smoothly, companies need a new way to observe and address critical issues. That's the focus of Apache Pinot, an open source distributed database designed for real-time analytics. How does it work and how can it help you? Check out this episode of Future Proof to find out.
The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
Yours truly, Eric Gavanaugh, here with a couple experts in the field. We're going to be talking to my good friend Hyoun Park of Amalgam Insights, and we have Kishore Gopalakrishna as well on the call with a company called StarTree that's doing some very interesting things in the world of data. And a couple quick thoughts about the topic, a Pinot for your thoughts, next-gen observability. Yes, okay, Pinot is an Apache project. Of course, it's also a wine, Pinot Noir. The wife loves that, Pinot Grigio, so people know Pinot. But it is an Apache project, and we're going to talk about that today. We're going to talk about observability and really meta observability to a certain extent and what that all means. And Gopala spent some time, Kishore spent some time over at LinkedIn and before that at Yahoo. And of course, LinkedIn is where Kafka came from. And Kafka has taken the data world by storm with its ability to stream tremendous amounts of data. The problem with Kafka is that there's a bit of an impedance mismatch. So they came along, figured out this great way to set up topics that stream tremendous amounts of information, but how you capture that and do things with it becomes a bit of a challenge. And being able to analyze it as it's flying across the transom, that's kind of the holy grail, if you will. And that's what these folks at StarTree have figured out. So being able to analyze data as it arrives, that's very compelling. Because if you have to wait for the warehouse, well, how long does that take? Is it an hour? Is it a day? Is it a week sometimes? You never know, depending upon the installation. And let's face it, sooner is better, especially if bad things are happening, you want to know right away. If good things are happening, you also want to know right away. And then observability, what is that? We're basically now able to see into these environments, into the data pipelines, for example, into the data sources and understand what's flowing and what's not flowing. So you get a baseline, you understand what's supposed to be happening. And then with observability, you get early warning alerts, basically, that something isn't right. And so that's great for data teams because they know, all right, we got a problem here, we have to fix something. So they can go in and fix it, and you don't wind up making decisions on bad data, on missing data. There's a lot of technical aspects of getting this all right, but it's very important. And I was said on the call when I talked to StarTree a couple of weeks ago, as they told me about the technology, I was like, you're reminding me of another company we did some work with, a company called Mesmo. And what they do is they sit on top of observability feeds, and they allow you to select the signal you want to keep and also just persist in maybe cold storage, all the other stuff that you don't necessarily need. Because the fact is, once you start with these observability vendors, whether it's New Relic or Datadog or any number of them, there's like 20 or 30 of them these days. At first, there's not a whole lot of data, but as time goes by, there's a lot of data, and you wind up spending a whole heck of a lot of money for storage. And on the other side of the equation is that it's always in the correlation of these feeds that you're going to find your insights. So how do you correlate? How do you reconcile data feeds from 5, 6 different systems? It's very difficult to do. And the folks at StarTree are also working on that in particular. So I think it's very interesting technology. It is very good for keeping the machines running on time, the trains running on time, if you will. And that's just crucially important in today's hybrid cloud world. And with that, Kishore, I'd like to bring you in to tell us a bit about StarTree, what you're working on, and where the idea came from, maybe. So tell us about StarTree, Kishore.
Yeah, absolutely. Again, first of all, thank you so much for having me on the show. That was a great intro and a great segue into kind of why we built Apache Pinot and also why we started StarTree. StarTree is a company that provides real-time analytics platform as a service, and is built around Apache Pinot project that you kind of hinted at in the beginning. And one of the key things that we really built this for was really bring analytics to the masses, right? So when I say that, it's like something that we found at LinkedIn, that analytics should not be restricted just to the execs, right? I think I touch upon this part of decision-making process that you also mentioned that, and that has evolved quite significantly in the last decade or so, right? And I think when I think about decision-making, there are two parts that comes to mind, which is really the quality of decision and the speed of decision making, right?
Hmm.
And quality, I mean, we all know, I think this has been there for since the start of big data is like, you need to make decisions based on data, right? You don't want to just make decisions out of your previous information or any kind of hypothesis that you have. And the second part is the speed, and that's where Pinot came in, right? Which is the events are happening. Why do you have to wait for the next day to actually make those decisions on the data? So
Hmm.
that's where we were able to provide those insights to make quick decisions, and you don't have to wait for another day or two. And I think the second, which is very interesting and something that we found at LinkedIn, is there is also a major change here on who is making the decision. I think that was a very important factor for us to build this project, which is if you go back 10, 20 years ago, it was only the execs or the product managers who were making the decisions based on data. It almost used to be this luxury that you had in the company that only for some people could have access to this data. But that is something that we found at LinkedIn that everyone should be making decisions. It should not be restricted to these elite people within the company, because the more decentralized decisions that can be made, the better it is and the faster the company evolves. And not just that, what about your users and what about your consumers, right? So LinkedIn, we thought about what decisions are the members of LinkedIn making, and that's kind of what changed the whole game for us in terms of thinking about analytics as it's no longer something that's batch, and it's no longer something that's restricted to some certain set of people within the company. Can we make it real time? Can we open it up for the entire world? And that was like a kind of an experiment, I would say, to begin with at LinkedIn, because we were also trying to solve the engagement problem, but it opened up a completely new set of data products that we could build. And then if you see LinkedIn today, like pretty much any number on LinkedIn, it's basically a real-time analytics
Wow.
powered by Pinot. Right?
Yeah, and so I've been in this analytics space for a long time. I first got into it back in 2001, and I just knew that data was going to be big, and I also knew that analytics was going to be huge. And being able to crunch the numbers and really get an understanding of what's happening, that's the key to analytics. And it's
Yeah.
all about, to your point, making better decisions. It's funny, we talked about business intelligence for the masses 23 years ago. It
Yeah.
took us a little bit longer than I expected, but it's here now. And I think Kishore, my impression is that once someone can see the analytics and use that capability, they don't want to go back. It's
Yes.
like being able to flip a light on in a dark room. You don't want to turn the light back off and try to find stuff. You want to
Yeah.
turn that light on and see. Isn't that right?
Yeah, no, absolutely. I mean, a lot of people, I think one of the things that when I talk about this, people say like, I don't need it. And I'm like, hey, you're using it on a day-to-day basis. You open up your Uber Eats app and you're actually looking at how long, which restaurant am I going to pick? And then you're picking based on like how long it's taking to serve that. Guess what? That's real-time analytics. Real-time analytics doesn't mean that you need to see a chart and it's like it's any number that is actually computed in real time. That's basically the definition of real time analytics. And imagine now going back, and if you want to order something, someone calling a restaurant and then calling multiple restaurants and asking how long are you going to take to order to serve this order, and then making a decision. There's no way we are going back to that, right? And with all the Ubers and DoorDash of the world, this like completely changed the way we think about food, the way we think about travel. You're no longer calling a taxi to actually go to from one place to another. So this is like the change has already happened, and it's just more about people noticing that and seeing that, hey, there is something behind the scene that's actually making it possible.
Yeah, and you bring up another excellent point here, which is that what we see in the consumer world is driving tendencies and expectations in the business world. Now, you
Yes.
think about how Uber revolutionized the whole ride sharing concept and getting a taxi service, basically. And let's face it, yellow cab and taxis were just living in the Stone Ages.
Yeah.
And all of a sudden, when you can see the car around the corner on your phone,
Yeah.
that's a huge deal. And we're seeing the same thing now in the real business world because people can see what's happening. And when you can, at the other side is comparisons. When you can compare what you're doing with what other people are doing, and you can see that comparison, it's really a strong driver for change and for efficiency, right?
No, absolutely, absolutely. I think in other words, there is also this consumers are actually forcing businesses to evolve because this is becoming almost like a competitive edge. And at the same time, the consumers are very demanding right now, right? And if you think about it, if someone on the other side, let's say Uber doesn't know sudden surge in some demand in some area, let's say there is a sudden event that happens, and if they don't react to that, and if they are not capable of knowing that, they already lost that advantage, right? And someone else would have acted on it, and someone would have capitalized on it. So it's almost like becoming like a going from like a nice to have, it's a good competitive edge, to is like you got to have this, otherwise your customers are actually moving to another platform because they have so many other options.
Yeah, yeah, that's an excellent point. And over the course of the show, I do want to get into the weeds with you a bit about how Pinot is different, what StarTree is actually doing, and how that all works. But before we get there, let's bring in our esteemed analyst of the show today, Hyoun Park from Amalgam Insights. Hyoun, you've been around this business for as long as I have, and you've seen the changes, and it's really quite tremendous what's happened in the last decade and even in the last half decade with all of these solutions spinning out of the tech giants like Facebook and LinkedIn. Originally, it was Yahoo. That's the first diaspora came out of Yahoo. But now you're seeing all kind of cool stuff come out because these folks have been at the coal face, as they say. They've been tackling these issues, and they're issues of scale more than anything else, which is a whole separate set of problems. But what do you think, Hyoun?
Yes, so there's a variety of challenges here, and I still have to think about what if Jerry Yang had been able to keep it in control at Yahoo, because he really did understand all these scaling issues. But whole other story right there. When I think about data in general, I tend to think about it kind of in terms of Heisenberg's uncertainty principle. That there's always these complementary variables that are coming into place, like such as speed versus what is actually happening. Call it the momentum or position. These things are always in flux. You can know one, but not the other. As we're getting more real time, we've had this challenge. You can either understand your data in extreme detail, or you can get it updated. That has traditionally been kind of the trade-off that we've made, that comparison to position versus momentum that exists for uncertainty. But what we are seeing is that as we are seeing order of magnitude increases in data, as well as greater demands for real time. We're having to find ways to bring those two closer and closer together. And that has required different technology paradigms to be created over time. So for instance, when we started in data, we were all used to looking at structured data and traditional relational databases and input output that was pretty limited and required batches basically. We had to schedule those batches. Sometimes it'd take hours to upload and download. And we don't live in that world anymore, frankly. Those were the technical barriers that honestly kept a lot of legacy businesses alive. So we talked about taxis, for instance, and taxi companies associated that their immense physical footprint and the number of taxi people involved just made it too complex to be replicable in a data-based environment or a data platform. But finally, we got to the point where streaming and big data technologies allowed us to finally surpass that. And frankly, we are seeing that across every part of business. We are seeing these ecosystems that have millions and possibly billions of parts that have traditionally been considered too complicated to work in an IT world. So they are still running on 30, 40-year-old operational technology, but we're still starting to finally get to the point, partially thanks to work of Kishore and many other open source projects that have helped with streaming and input output and indexing rather than specific data, change data capture, all these things that are happening to make us stop thinking about data simply in terms of having to rip and replace over and over again, and starting to actually think about data at a granular level, at a real-time level, and at the massive scale necessary to replicate real-time processes. So a lot going on here.
Right at the end of that segment, I'll throw this over to you, Hyoun. Kishore made a really good point about data products and about enabling your teams to see the kinds of data necessary to give them the ideas and the material to build these products. And then once it's built, then you can roll it out and let people use it. And it's my experience when people get a good data product, they just love it. You sit there. I mean, Google is kind of like a data product, right? You just ask it questions because they did a bunch of work behind the scenes to index the web. This, of course, started at Yahoo, and it's where Hadoop came from, really, was indexing the web. But once you've got it, you love it, and everyone loves it now. And now we have Gen AI and all these other things. There are always some issues to be sorted out, but nonetheless, when you get a good data product, people use it, and then they start making better decisions. And so that's really the snowball we want to go down the hill here, is to get that excitement in the organization to figure out what these things are and then really start building them and using them, right, Hyoun?
Right. And from a practical perspective, we've wanted to turn data into products for a long time. But what makes it hard is that there are so many different pieces to this. It is easy to be a technician and simply say, we have created the data store, the initial single source of truth that we're going to use from a data perspective, and say that's the product. But from a reality perspective, you also have to think about the analytics, the outputs associated with that data product. You have to think about the ongoing maintenance of that data source and the outputs, the infrastructure that's involved, which obviously we've wanted to throw this all to the cloud and starting to see that perhaps we need to pull some of this back in-house over time, especially as we're starting to think about AI. And then also thinking about just how this is going to scale over time, because honestly, we are all living in a world where things like Moore's Law and just the growth of data are just relentless. Everything is doubling every 12 months, 18 months, 24 months. You can pick your time period, but the end result is basically every decade, we're seeing something like 100x growth in everything that we build. So anything that we build today in 2024, we just have to assume a decade from now, if we are successful, this is going to be 100 times bigger at the very least. And this is even without assuming that you have great growth and 10x or 100x your company, in which case you've got a 10,000x challenge compared to what you have today. And your architecture and data plans have to at least take that into account, the potential for that success and the ability to move forward and adjust your data, the velocity of your data, the variety of your data over time to account for these inevitable changes. This is predictable. At least this growth is predictable, that it's going to be massive.
Yeah, and it's a good point, and it's also important to note that at certain stages of growth, things change. You just get a whole different dynamic. You see this in companies, like 1 to 10 employees is very different from 50 to 100, which is very different from 1,000 to 5,000. And you need people who can manage in different ways. You need people who can articulate and communicate in different ways and partner, and all this comes into play. And then you see the same sorts of dynamics in systems. When systems go from 1 node to 10 to 100 to 1,000, you run into different problems. And Kishore, I'll throw it over to you. That's the kind of stuff you folks experienced at Yahoo and at LinkedIn. And so you have the experience, you know what it's like to go hacking through those forests. And it's, I'm sure at times bewildering. And this is where a lot of the good ideas come from, of like, hey, wait a minute, if we can instrument this one system, then we can get a feed to understand what's going on. That's kind of where observability came from, right?
No, no, absolutely. And I think you mentioned about the scale. It's funny. I really got into this because of the quote at on distributed systems is like, it's funny that your system is rendered completely useless because some other system is down somewhere else. And it's like, you can't really grasp that, hey, my system, why is it useless? Because something else went down somewhere else. That's the real challenge of a distributed system, right? It's like something goes wrong somewhere and then something else is not working. And then you need to somehow correlate all these things and get to the root cause. And I think for me, you mentioned about observability, but it's been there for a long time, right? I think, but the two important things in observability is really the MTTD and the MTTR, right? It's like how long do you take to identify the issue? Because there's so many issues that just to go and identify, right? And we used to have this chart. We had like a big black hole in the center, and we would say like how many issues actually were here that you probably realized 1 year later, because it just continued to become bigger and bigger, and that's when you realized. And this was like, hey, you launched a feature 6 months ago, and suddenly you get to see the impact of that now, because it's just no one was tracking the exact impact of that. So the first one is the MTTD, which is how long do you take to identify. And the second part, which is actually very important, and most people actually ignore this, is the MTTR as well, because you can't really fix the issue unless you know why it happened. So that question of why is actually super critical. And most people just focus on the first part of detecting. And that's actually sometimes a lot more easier, because it's right in your face. It's like your revenue is going down, or like the number of traffic, number of visits to your company is actually going down. But going from there to actually fix involves this intermediate step of figuring out the root cause, because you are just looking at the symptom and you have no idea what the root cause is. So I think observability is needed for the second part as well, because that's where you will be able to correlate. It's not just one data point that you can actually look at. It's, to your point earlier, is like how many feeds do you need to collect? How many data sources do you need to actually observe? And I think that's, so I think overall, in terms of observability, it's about making sure that you have access to all these data points and all these events. And it might be sometimes the CPU, it might be sometimes the memory, it might be something completely different that you had not even thought about. And I think it's really fascinating to be in a stage right now where logging these events and collecting them is no longer a challenge, right? And that used to be a challenge for 10, 15 years ago. And I mentioned this in my keynote as well at Yahoo. We used to have this T-shirt that every event that you log, a kitten dies somewhere. And this was to discourage people from logging event because it was so expensive, right? So like imagine going from that era to like you're pretty much tracking everything, and even if you don't want, your watch is probably sending your signals, health signals every second, every microsecond. So I think that to Hyoun's point of like everything is going to be 100x. Yes, that is absolutely true. It's going to be orders of magnitude. And what we need is systems that allow us to still analyze all this data, but the unit cost per analyzing each event drastically goes down, right? I think that's kind of how we see, and that's one of the things that we started off with Pinot is how do you reduce the cost per query, right? How do we? So that's the way we looked at it. And if you look at Kafka, and it basically did the same. It's not like there were no event logging systems before Kafka. There was RabbitMQ, there was ActiveMQ. But it was, what people didn't realize is the cost of every event was actually very high. That prevented people from logging it. But that changed. And that's what we are changing with Pinot as well. Like you should be able to query as many number of times, and you should not be thinking about, oh, what's the cost of, why I ask this other question, is it going to increase the cost? And that's where data warehouse actually didn't deliver on the promise, because if you look at the cost per query on a data warehouse, it's very expensive. Compared to the systems that we have actually built.
Well, and this is, and so just for our audience sake, median time to identify and median time to resolve, right? These are the metrics that you're talking about, and it also has to be tracked. Like, how long does it take you? Is it a minute? Is it an hour? Is it 5 hours? And when it gets really bad, it's like, okay, guys, something's going on here. We got to retool and rethink things. And Hyoun, I'll throw it over to you just to help our audience understand. I think it's so fascinating what we've seen again coming out of these tech giants, because they realized, like Facebook goes and creates Cassandra because they realized there was no database on the market that could do what they wanted to do. The scale was so significant. It's not like they can go buy SQL Server and run Facebook on SQL Server. It ain't going to happen. And so they had to roll their own, right?
Yeah. And also, we've been running into a new era of IT observability, where we really have been able to think at the packet level and go from network observability, application-based observability, database observability. And these all used to be separate systems that we all had to coordinate to get things done, because each system actually looked at a different level of IT activity. And then we had to kind of align all these to figure out what was actually happening at the most granular level. Now we actually have the data tools and to be able to look at activity in near real time. I always say near real time because somebody's always going to quibble about whether it's a millisecond or a nanosecond or whatever. But I will say that if you're looking for what's happening within the last few seconds, we have the technology now to figure out what is basically happening in near real time. And that really opens up a new level of visibility from, I would say, going one step back, thinking about data as a product. Now we can actually think about the margins associated with each data product, because we actually know how much it costs to run a data product to a greater extent now. Whereas before we had to do a lot of guesses. We could look at this network part, we could look at the storage part, we could look at this compute part, we could look at all of our separate systems. But now we're starting to have this one actual view of, at that lowest common denominator, of the actual data that is involved across applications and transactions, and saying, here's the actual cost of the application at the end of the day, or the product that we have at the end of the day, and be able to make better business decisions at the end of the day, which is, I think, the more important and practical aspect of all of the progress that we're making from this IT and data scaling perspective.
Yeah, that's really good stuff. And Kishore, I'll throw it back over to you to get back to this key point, which is concurrency, concurrent users. In the data warehousing space, companies like Teradata spent years engineering to be able to deliver concurrent analytics, because it gets kind of hard. If X number of people are all hitting these tables and those tables, things are going to slow down. That's going to cause trouble for concurrency. And so they had to engineer for that. And here with a company like LinkedIn, with a service offering like LinkedIn, think about how many users you have logging on all the time. So you need to have a distributed architecture. It needs to have tremendous failover capabilities, and it needs to be able to break things down into little bits and processes as the use cases come in, right? As the activity increases. And everyone who logs on to LinkedIn knows it's like you take it for granted. All that stuff is there, but there's a whole lot of engineering that goes on in the back room to enable that kind of scale, right?
Yeah, no, absolutely. And I think one of the things that we did was to first understand how data warehouses were solved, because this has been there for like 10, 20 years. And I think one of the things that I definitely didn't want to do was build another database, because I had built one before Apache Pinot, and I knew how hard it is, and I tried every possible thing to not build another one. And then it's
That's
that
funny.
to your point, I think it's fascinating when you actually go to the first principles and then see, like, why is this not working in data warehouse? I think one of the key insights that we found was most of the databases approached it from the angle of, this is the amount of work that we need to do to serve a query. How can we make it fast, right?
Yeah.
But that's where we came up with a different approach, which is like, maybe we shouldn't be doing this much amount of work. Can we actually reduce the amount of work instead of trying to keep the work the same and then try to do it faster by doing SIMD, by doing columnar, by doing distributed architecture? Those are all like things that people had applied. And that's where we came up with a different approach of like, maybe we shouldn't be doing all this work. How can we eliminate the work instead of trying to do the same work faster? And that's where the idea of indexes were born. And we kind of went all in terms of thinking of indexes as a first-class citizen, not like a nice to have and an add-on later, right? So we kind of went all in on indexes. We went all in on real time as well, because that's another part that data warehouses didn't. It was always batch load that you could do in terms of data warehouses. So we wanted to be able to ingest data, and we put a very, very hard line on, there is no micro batching. There is no, oh, we'll do like 1 minute, 5 minutes, because the challenge with these micro batching is like, once you fall back, you're never catching up.